We aim to convert the given galvanometer of known resistance and figure of merit into a voltmeter of desired range. And to clarify the same, I am Atul Gupta. I am PhD in physics, appointed as lecturer at Government Senior Secondary School, Nangalpur, Pathankot. The apparatus required for this experiment is 2 resistance boxes, battery eliminator or power supply, a rheostat, a voltmeter, a galvanometer, connecting wires, sandpaper if required. This is the resistance box having different keys. It ranges from 0 to 10,000 ohm. This is another view. Here we have removed some keys. See, 2000 ohm, 2000 ohm, 50 ohm and 10 ohm. It means 2000 plus 2000 plus 50 plus 10 means 4460 ohm resistance is removed from this resistance box, means a resistance of value 4460 ohm is introduced in the circuit. Another resistance box is used of value 0 to 500 ohm. This is the power supply. It gives DC output. It has 2 terminals. Red one is positive and black one is negative. It has a variable voltage in steps of 2 volt. It gives 2 volt, 4 volt, 6, 8, 10, 12 volt. This is a rheostat. It is a variable resistor giving the different values of resistances. It has 2 fixed ends and 1 movable end. It is a voltmeter. It ranges from 0 to 5 volt. But in this experiment, I will demonstrate to make a voltmeter of 3 volt. Because of simple calculations, galvanometer has 30 divisions on it. So it is very easy to convert a 30 division galvanometer into a 3 volt voltmeter. So I will convert a galvanometer into a 3 volt voltmeter. So I will use only 3 volts of this voltmeter. This is a galvanometer. Clearly you can see it has 30 divisions from 0 to the right or left side. What is a voltmeter? It is a device that used to measure potential difference. What is the condition for measuring potential difference? Means how potential difference can be measured. Voltmeter must be connected in parallel because voltmeter measures the potential difference and it must be connected in parallel. So if voltmeter is connected in parallel, then what must be its resistance? High or low? Definitely high. If a device is connected in parallel, like voltmeter, it must not draw excess current. So for that, a high resistance device must be connected in parallel. So how resistance can be increased? The resistance of circuit can be increased if a resistance is connected in series with the device or in the circuit. We have to convert galvanometer into voltmeter. So we have to increase the resistance of galvanometer. How we can increase the resistance of galvanometer? We know that there are two combinations. One is parallel combination, another is series combination. Series combination has higher value of resistance than parallel combination. So by connecting a high resistance in series, the resistance of galvanometer can be increased. This is shown in the figure. A galvanometer is connected with a high resistance. This R is a resistance from resistance box. Ig is the current that is flowing through this circuit. It is a series combination of galvanometer and a resistance box. This is a voltmeter. In series, the current flows the same. That's why if Ig current is flowing through galvanometer, then same current is flowing through resistance box or resistance or resistor. But in series, the potential difference is always divided, or simply here the potential difference across G and across R is to be added. The potential difference across galvanometer is G into Ig by Ohm's law, and across R it is R into Ig. So for desired voltmeter range V, this V will be equal to Gig plus R into Ig. So this is the formula which we use for conversion of galvanometer to voltmeter. So R is equal to V upon Ig minus G. R is the resistance from resistance box in ohm. V is the desired voltmeter range. We have set it to 3 volt. Ig, the full scale deflection in ampere. G, galvanometer resistance in ohm. So R can be calculated by knowing the value of V, that we know 3 volt, but Ig, the full scale deflection, and G, the galvanometer resistance, is not known. Further, Ig is equal to N into K, where N is the number of divisions on galvanometer, that is 30 divisions we have already shown, and K is the figure of merit. Means it is the current required for one deflection. Its units are ampere per division. So for calculating the full scale deflection Ig, we must know the figure of merit. So we first of all have to calculate the value of figure of merit K and galvanometer resistance, and this can be measured by using half deflection method. This is the circuit diagram for half deflection method. A series resistance R is attached with galvanometer along with the battery illuminator, giving EMF E and key K1. I is the current flowing in this circuit, and of course a shunt resistance S attached parallel to the galvanometer with K key 2. The excess current I minus Ig flows through shunt resistance because I is greater than Ig. So let us calculate first the value of galvanometer and figure of merit. Measure the potential difference from this voltmeter, that is 4.8 volt. Connect the apparatus as shown in this circuit diagram. This is a key K2, a resistance box called shunt resistance, a series resistance box, galvanometer, a key K2, power supply. Now take two copper wires, attach with galvanometer, one end of the galvanometer, one wire with resistance box connected in parallel. This resistance box is of 0 to 500 ohm. Its value is less than that of the series resistance box, and this series resistance box has a range of 0 to 10,000 ohms. After connecting these wires, take another copper wire, connect it with the shunt resistance and connect it with the one terminal of the key K2. Take another copper wire, connect the second terminal of key K2 with this wire and attach it with the galvanometer as shown in the figure. So this is how we are connecting the wire. Take another wire, attach this wire with the galvanometer and the key K1, and the one more copper wire connected with the second terminal of key K1 with the negative of the power supply. So the last connection is as shown. This is connected with the positive of the power supply with the one end of the resistance box. So after checking the connections, tight all the keys in resistance box. No key should be loose. Similarly, check the second resistance box, tight all the keys. After tightening all the keys, insert key K1 and that key K1 after inserting, we have to remove some resistance from the series resistance box to make maximum deflection. For that, remove some keys. So I am trying to get 30 divisions on the galvanometer, means maximum deflection. So note down the value from the resistance box: 5000, 2000, 500 and 200. So it is a total resistance of 7700 ohm. That is value of R, and theta is 30. Insert key K2. You will say a zero deflection in the galvanometer. It means circuit connections are okay. Remove keys from the shunt resistance box so as to make 15 divisions, means half deflection. And seeing the galvanometer, we have obtained 15 divisions. Note down the value from the shunt resistance box, that is 80. So calculate the value of galvanometer resistance using the formula Rs upon R minus S. You will get a value of 80 ohms resistance of the galvanometer. So let us reduce the deflection from 30 to 28, remove some more keys, increase the resistance, adjust the values, and you see here we have obtained 28 deflections, and note down the resistance from the resistance box, that is 8200. Now insert key K2. You will see automatically galvanometer is showing now 14 divisions. The shunt resistance remains same, that is 80. So 8200, 28 is a deflection, 14 is a half deflection, 80 is the shunt resistance, and use this formula again, Rs upon R minus S. This is again giving the value of 80 ohms for the galvanometer resistance. Now reduce 28 to 26, remove some more keys, adjust, and you see we have seen a 26 divisions. Again calculate the value from the resistance box. This time the value is 8800. From the series resistance box, deflection is 26, half deflection is 13. That we have to check after inserting the key K2. Automatically it is 13, and S remains the same, that is 80. So put these values in the table, 8800, 80, 26, 13, and again use this formula G is equal to Rs upon R minus S. This gives the value equal to 80 ohm. So now take the mean of the galvanometer resistance, means add all three readings, 80 plus 80 plus 80 divided by 3, and this is. So we have obtained an observation table where we have obtained the value of R from the series resistance box and from parallel resistance box, that is S shunt, and deflection and half deflection. So corresponding to each reading we will obtain the value of galvanometer resistance by using the formula G is equal to Rs upon R minus S, as we have obtained already, and we have calculated the mean of G, that is 80 ohms. Now let us find out the figure of merit K. For each value, use the formula K is equal to E divided by R plus G into the deflection. E, the potential difference or the EMF, 4.8 volt. Obtain the mean of the K, that is 0.000022 ampere per division. Use this K for calculating the full scale deflection Ig. Use the formula Ig is equal to Nk. N are the 30 divisions in the galvanometer. Put the value of N and K, and we have obtained the value of the full scale deflection Ig, that is equal to 0.0066 amperes. Now we have to convert galvanometer to voltmeter. For that we use the formula R is equal to V upon Ig minus G, and we have to make a 3 volt range. So put the value of V, Ig and G. We have obtained 4458 ohm resistance. So least count, as usual we are talking about it. Galvanometer has 30 divisions which are equivalent to 3 volt. So it means the least count in the galvanometer for the voltmeter is 3 by 30, that is 0.1 volt. Example, if we have a pointer on 20 divisions of the galvanometer, then it means 20 into 0.1, 2, means it is a voltmeter of 2 volt. Yeah, means we have converted galvanometer of 2 volts. This is the circuit diagram for the conversion of galvanometer to voltmeter. So connect the apparatus as shown in the circuit diagram. This is a resistance box, one-way key, a power supply, and rheostat connecting wires, galvanometer. So take a copper wire, attach with the negative terminal of the power supply, attach it with the key K1 in the circuit, and second terminal of the key is connected to the rheostat. This is a rheostat. Attach its lower end, that is a fixed end, one of the fixed end. Attach here, make tight connections. Take another copper wire and attach it with the second fixed end of the rheostat. Now attach this wire with the positive of the battery eliminator. Now this circuit is a voltage divider circuit. Take one more copper wire, attach it with the lower fixed end of the battery eliminator and attach this wire to the galvanometer. And here how we have connected with the galvanometer. This is a resistance box. Take another copper wire to attach the resistance with the galvanometer. So by attaching, we have completed the circuit. Again, take one more wire and connect it with the voltmeter. Take one more wire and connect it to the negative terminal of the voltmeter. So now the voltmeter is ready to connect. So attach positive of the voltmeter with this terminal of the galvanometer. This is a terminal which is connected with the positive of the battery eliminator. Be careful in connection of this positive terminal of voltmeter. See, here it is connected with the positive of the power supply. Now take one more wire and connect it with the resistance box. Make all the connections, and the last connection that is left is with the movable end of the rheostat with the resistance box. So check all the connections properly. After checking all the connections, tight all the keys in the resistance box. Be careful, no key should be kept loose, otherwise a resistance of that will be introduced in the circuit and our reading will be affected by that. So that will introduce an error. So from calculations we have obtained earlier, a resistance of 4458 ohm makes a 3 volt voltmeter. I am considering it as 4460. Remove the keys 2000, 2000, 50 and 10. So I have introduced a resistance of 4460 ohm. Insert the key in the circuit and remove. Now adjust the rheostat resistance, move its variable, and this will adjust the reading equal to for the voltmeter. We have a least count of 0.1 volt. So if it has 30 divisions, it means 3 volt of the voltmeter that we have to check, and check it for the maximum deflection, means 30 divisions in the galvanometer and 3 volt in the voltmeter. So we have adjusted the value and it is a 3 volt showing 30 divisions. Now move rheostat slowly and also have a watch on the voltmeter to make it a 2 volt, and correspondingly 20 divisions in the galvanometer means 20 into 0.1 will make 2 volt voltmeter. Now this galvanometer that is showing, so 2 volt voltmeter is showing 20 divisions corresponding to the galvanometer, and that is a 2 volt voltmeter. Now so again adjust the reading. We have drawn a result that the galvanometer resistance is 80 ohm. Of course, the full scale deflection Ig 0.00066 ampere. The resistance for 3 volt voltmeter is 4458 ohm, and finally it is clarified experimentally that galvanometer can be converted to voltmeter of desired range.